Problem number 1567, maximum length of subarray with positive product. Given an array of integer nums, find the maximum length of a subarray where the product of all its elements is positive. By the maximum length. Okay, so yeah, we have to return the length, the maximum length of a it's a subarray, not subsequence, and the product of all its elements is positive. A subarray of an array is a consecutive sequence of 0 or more values taken out of that array. Sequence of 0 or more values. Okay, so it can have empty array. Return the maximum length of a subarray with positive product. Okay, the length of the nums array is at least 1, and there will be negatives and zeros, positives, integers in the array. I am curious about 0. Yeah, like if I have I'm not sure if I have, or maybe this, like what is the answer? Length, is it 0? If 0, then yeah, not so 0 or more values. I think I would like to test, like maybe add it like this, and you can just return 0 and check. Oh, okay, it's 0. So for we can take 0, like nothing. Okay, so it has to be a subarray and with product. Okay, so for there is negatives in, and we want to have products, then it must have like maximum and minimum at the same time. Then I think so the default value will be 0, since we can take empty array, like we can have empty subarrays, and it wants us to return the length. For returning the length, like it is not so maybe let's look at the last element. So for the last element, we can like we can so it does not it don't want like the maximum value of the product it wants as long as possible, but it should stay positive. And it is a subarray, so yeah, I'm thinking like when we are here, then it will be like the previous length plus 1, or so if okay, maybe like we can like we can start with the example. It has like this. So when we start at 4, we will try like the previous. Like we don't care about the value, we only care about the symbols the symbols of the value, like it is negative or positive. Okay, so when I have a positive value, I will like the previous stuff is positive. And if I have a negative value like -3, I would like my previous subarray to be negative. Okay. So yeah, so if norms I is positive, then okay, and 0 does not count as positive. Okay, so if norms I is larger than 0, we want previous array to be positive, to array larger than 0. And if norms I is negative, then we want previous array smaller than 0. Okay, so I think the value is not important. And is there any other options, like if we don't, we can also don't select, like like maybe we can define the length of the array that ends at norms I. So because if this is if this is positive, then we can add this. But if like it, yeah, this is negative, then I will only want to add this. So, yeah, I think I would like to know like the previous array length with positive and negative. Yeah, like the longest positive array in, yeah. Like if nums is larger than 0, then previous array is 0, then the length can be added by 1. But okay, so like I think it's a bit like the previous problems. If yeah, and I would like to know the length of negative product subarray, and yeah, max length of negative product subarray and max length of positive product subarray. Yeah, kind of connecting it to each other. Like if I have the previous max length of negative product subarray, if my nums is like if nums I is larger than 0, then the maximum length of the positive product subarray can be added by 1. Okay, I came up with some idea, like we can define df as I as it can return 2 values, like the maximum, the maximum length of negative product subarray ending at nums I, and yeah, negative and positive. So yeah, like if we have the negative, this is a positive maximum length ending at -3, so it is 3, and when it comes to 4, we have a choice, like adding, like no choice, but we can, yeah, like the positive array can be added by 1 and the negative array will be 1. Oh, like we should see like okay, so for this let's say df as I equals if it's I minus 1, like this is the maximum and minimum, the maximum length of negative and positive products of array. So let's have df as positive or plus 1 if nonce I larger than 0. Else in DFS I will be okay, let me think. If negative I minus 1 or plus 1 if nonce I is smaller than 0. For this, the time complexity will be big O(n), since it only has one parameter and I has a size n. But I am thinking, I'm thinking if there is other options. When it is like when nonce I is positive, okay, maybe we are at, okay, when we are at 1, it is positive, so positive length will add 1, negative stays 0. And when we are at negative, then negative is 0, positive is 1 now, and when we add negative, then the negative will be added by 1 and positive will stay with, positive should be 0. Okay, something, like when we are at 1, I'll say like this positive and this negative length, and this will be 1, this will be 0. When we are at negative 2, positive is 1, negative is 2, but it is smaller than 0, so it will be added by 1, and positive should be 0. And when we are at negative 3, negative and negative can be added by 1, so it is 2. And positive, I think positive will be 2. Yeah, positive should be 2, and then negative should be, no. Oh, I think it's not a good idea. Like for this, negative or positive should be Positive should be 1. Yeah, it's like the subarray is this, and it is a negative, so it will have, it will have we'll have 2, and positive will have so for each element, if we look at its positive, for 1 we have -0, +1, and for -2, negative is 2, length of 2, maximum length, and for positive there is it like sub? No, it is not, it's subarray, so we will have 0. Yeah, subarray ending at this, there's only this and this subarrays. And for -3, there is positive for, it is 3. Yeah, and this is also a subarray, 2. And this is negative, it is 1. And for 4, the positive will be 4. And yeah, this is all positive, and negative will be 2. Okay, so, and we will see the positive, which one is the largest, and it is 4. Yeah, if we do it like this, it will be an O and with the power of 2. But so we would like to optimize, and to optimize, yeah, we would like to use the previous results, and like 4, we can use like 3 plus 1 since it is positive, and negative, it has 1 and we can add it, since to make it like to make it a negative, like the before value should be negative, and it is 1, so this is positive, then we will have 2. And for like when we are at 3, the positive value is 0. Yeah, but we cannot add it by this. Yeah, there's no way. Oh, but there's 2 negatives here, and to become a positive, so if I kind of finding like a state machine thing that is and a bit like the product subarray problem. So we can say if DSI we will have maybe is positive, or we can say positive p, maybe p. So yeah, the p represents negative or positive we want now. So for for DFSI, like p will be only 0 and 1. And for 0, that means we want to find, like, the current value is negative, and to find wait a second. Like this one, this is 0 and 2. For -3, to make a positive, yeah, this is positive. To make a positive thing, I would like to use the negative part and to add 1. And to have a negative thing, I would like to have a positive before me. So yeah, and this will be added by 1. Okay, I think maybe you don't need this positive stuff. Okay, I will try. So first of all, it is the length of, n will be the length of nums, and we will have the recursion DFSI, and yeah, we will talk about the boundaries later. So let's make a to-do. Boundaries, and for the values that are not at the boundaries, yeah, we will have like the previous array negative length, and we'll have positive length, negative length of the previous subarray that ends at I minus 1. And for this array, we will be, so if nums I is, okay, I think we should do, yeah, since we need to return both of the thing, like this will be positive and this will be negative stuff. So I will have positive, okay, so if say if the current value, yeah, I think this will be easier. If the current value is larger than 0, we will return positive plus 1 and negative okay, let's see if positive, negative will plus 1 as well, since if the negative is 0, but if 0, then we will not add, will we? Okay, well, let's see. If this is like the previous is positive and negative 0, for negative we added, since it is smaller. Okay, maybe let's first do if nums I is smaller than 0, then the positive value will be negative at 1. Okay, let's see. Negative is 2. The positive value of this will be negative at 1. And the negative value for this will be positive at 1. I think it's a bit like some little mistakes are inside. Yeah, I think I'm not doing the same thing for this every number. Let's try it again. So, okay, so the first thing, it will be started both from 0, 0. And, okay, so maybe not, but like the first element will be, it don't have to look back, so it will start itself. And it will be, since it is positive, the positive length will be 1, negative length is 0. Okay, and the next value is negative. Okay, yeah, so positive plus 1, negative will not move. But when we look at the next negative value, yeah, like we will not know the previous is positive or negative. So, but we know the previous length of the positive is 1. So for 1, now I am negative. If I want, yeah, like now we are asking the current positive length. Since I am negative, the positive length will be, yeah, I cannot continue, so the positive will be, yeah, we cannot add 1. But negative, since the previous thing is positive, so I will use the positive to add me, myself, and it will become a negative array. So yeah, I can add negative by 1. Oh, this will be plus 1. But negative, yeah, like when negative, or it is a 0 or 1. Yeah, if I think it's not really solid. I think it's a direction, like a good direction, but I think I missed something that yeah, like for this I did not, the positive thing I cannot add 1 to it's okay. So for like it is negative, then its positive length will be the previous negative, yeah, and its positive value will be the positive plus 1. Okay, this is correct. But when it turns this, like it is negative, so its negative value, okay, so its positive value will be negative. Yeah, it should be +1. It has positive +1, correct? Oh, its negative value is positive +1. Yes, this one is correct, but this is not. Okay, I'm thinking maybe if we use state machine thing, will it be easier? Or is it because yeah, we did not add its positive value from negative. Or there is an option? No, but there's like no option. It has to be 0. Okay, maybe let's check the solution. Yeah, my definition is correct, but here there's not sure what happens. Oh, it says okay, yeah, so it has like positive and negative. And if x is larger than 0, for the negative, it should +1 if oh yeah, it's the 0 thing. Like if it is 0, then we can +1, but no, then we don't. We will return Oh, then we had to return 0. Okay, so yeah, this is important. So like if only plus 1, I'm sorry, it says, okay, so if x is larger than 0, for its positive it will add 1, but for its negative, yeah, like if neg is larger than 0, then negative plus 1. Okay, so plus 1 only, yeah, like this else 0. Okay, cool. Why is it like yeah, it explains this, like so when, yeah, this is also when it is smaller than 0, it's positive. Let's see. When x is smaller than 0, the previous negative thing should be okay. Yeah, its negative thing should do this as well. Yeah, like, so for negatives, if the positive will be the negative, will come from the negative, and if it is 0, like if the previous thing is 0, then yeah, like yeah, why not okay, so for this, why they don't need to add the if else condition is because like when this, like when the current value is smaller than 0, its negative value, its negative length will definitely be at least 1. Yeah, so if this is 0, it is 1. So yeah, no matter whether the previous value is 0 or larger than 0. And when current value is larger than 0, its positive length will definitely added by 1. Like if the previous value is 0, it still is 1. It's at least 1. So we don't need an if else condition. But yes, like if the current value is positive, is larger than 0, its negative length, yeah, its negative length will be, yeah, we don't know, since if like, yeah, if the previous value, if the previous negative length is 0, then the current value will be, then the current negative length will be 0. But if the previous negative value is larger than 1, then since we have the positive value now, it can be added and it is still remain, and the whole subarray will still remain negative, so it can be 2. Yeah, okay, it makes sense. And when we look at if the current value is negative, it's smaller than 0, and it's positive length, we can say it will not be at least 1 because current value is smaller than 0. So if the previous value is 0, like the previous subarray doesn't have positives, then doesn't have negatives, then we cannot form a positive subarray adding the current value. So if the previous array negative length is 0, then we will have 0 positive length. But if the previous subarray negative length is larger than 1, then we can add it up our value and form a larger, like a longer subarray that has positive value, since so it should be added by 1. Okay, so far so good. And the next situation will be if nums I equals 0. It should return if 0, then there is no positive and negatives. It will start it from it will reset everything and start it again. So it should return 0 and 0. And so let's do the boundaries. For the boundaries, so we don't want I minus 1 to be out of bound. So if I is smaller than 0, it is invalid. Maybe like, so if I is 0, then we can return like positive value, like if nums I larger than 0, I think maybe we can have 0, 0 when it is out of bound. Yeah, I think it makes sense. And this is done. And so at the end we will have a maximum to see like which subarray has the longest positive. We will have 0. Okay.